The paradox of consciousness. Are we truly local? What if you're not just a collection of neurons firing electrical signals in the dark confines of your skull, but part of something much greater? What if, in the depths of your consciousness, you're not merely a product of the brain, but connected to a vast, invisible web that stretches across the entire universe? What if consciousness itself is not local to the brain, but instead exists as a non-local phenomenon, intricately entangled with the very fabric of reality? The mystery of consciousness is one of the most profound puzzles humanity has ever faced. For centuries, philosophers and scientists have wrestled with the question of how a physical, material brain can produce subjective experience, the rich inner world of thoughts, emotions, and self-awareness. Traditional views have placed consciousness squarely within the confines of the brain as a product of neural activity. But what if we are missing something crucial, something that lies beyond the biological processes of the brain? Could consciousness, instead of being strictly local, extend far beyond the brain, becoming entangled with the quantum fabric of the universe? What if, like particles in the quantum world, our minds are interconnected, non-local, and part of a grand cosmic consciousness that transcends the limits of space and time? This section will explore the paradox of consciousness, the tension between the idea of a brain-bound consciousness and the possibility that consciousness might be a non-local phenomenon, potentially linked to the very quantum field that underpins the universe. By examining ideas from quantum physics, we'll explore the idea that consciousness might not be confined to the brain, but instead could be entangled with the fabric of the cosmos itself. Consciousness as a product of the brain for much of modern science. The dominant view has been that consciousness is entirely local, tied to the brain and the nervous system. The neural correlates of consciousness, NCCs, are the specific patterns of neural activity that scientists have identified as being associated with conscious experience. This view holds that consciousness arises from the electrical activity of neurons, the firing of signals between cells, creating the rich internal world of thoughts, perceptions, and emotions. From this perspective, consciousness is an emergent property of the brain. As neurons communicate, complex networks form, and the brain becomes capable of processing sensory information, forming memories, and experiencing awareness. The brain, with its estimated 86 billion neurons, operates like a vast network, processing information and creating the subjective experience of being aware. Consciousness is simply the result of this biological machinery working in perfect harmony. However, this local view of consciousness leaves many questions unanswered. It fails to explain how the subjective experience of consciousness arises from physical processes. We can observe neural activity in the brain, but how does raw physical activity give rise to qualia, the ineffable, qualitative experience of being alive, of feeling and perceiving? Why does the firing of neurons lead to the vivid inner life of thought and self-awareness? This is the hard problem of consciousness, as famously framed by philosopher David Chalmers. Could consciousness be entangled with the universe? The mystery deepens when we consider a radically different possibility, that consciousness might not be confined to the brain at all. What if, instead of being local, consciousness is a non-local phenomenon, one that extends far beyond the body, entangled with the fundamental structure of the universe? Quantum physics, the science of the very small, has revealed a strange, counterintuitive reality that defies our classical understanding of the world. In the quantum realm, particles are not localized in space and time. Instead, they exist as probabilities existing in multiple states simultaneously until observed. This phenomenon is known as superposition. And then there's quantum entanglement, the idea that two particles, once interacted, remain connected no matter how far apart they are, with their states influencing each other instantaneously, faster than the speed of light. This non-locality is one of the strangest aspects of quantum physics, suggesting that at the deepest level of reality, everything is connected even across vast distances. What if consciousness is somehow related to these quantum phenomena? What if, like quantum particles, our minds are not confined to the brain, but are instead entangled with the fabric of the universe, non-local, and able to extend beyond the boundaries of our bodies and our brains? This idea suggests that individual consciousness could be part of a larger universal consciousness, much like individual quantum particles are part of a larger quantum field. In this view, consciousness is not simply a product of neural firing, but is entangled with the quantum field, a fundamental aspect of the universe itself. Just as quantum particles influence each other instantaneously across vast distances, could our consciousness be linked with a cosmic consciousness, transcending the physical body and interacting with the greater fabric of reality? Quantum mechanics and the mind, entanglement, superposition, and non-locality. To understand how consciousness might be non-local, we need to dive deeper into the strange world of quantum mechanics. At the heart of this theory lies entanglement, a phenomenon in which particles become linked, such that the state of one particle instantaneously affects the state of another, regardless of the distance between them. This is the very definition of non-locality. Could consciousness, like quantum particles, be entangled with the universe? Could our awareness be part of a larger, interconnected network, with each individual consciousness being a node in a vast cosmic web of information and experience? Some theories in quantum consciousness suggest that the mind may indeed be influenced by quantum processes, with consciousness not just arising from the brain, but being a fundamental part of reality, linked to the universe in a way that we cannot yet fully understand. Quantum physics also presents the concept of superposition, where particles exist in multiple states at once, only collapsing into one state when observed. Could our consciousness operate in a similar way, existing in multiple potential realities, timelines, or states of awareness until it interacts with the world and collapses into a single experience? This idea hints at a kind of multidimensional consciousness, one that is connected to multiple layers of reality at once and only appears as a localized individual experience when it interacts with the physical world. These theories suggest that consciousness might not be something that arises purely from the brain, but instead is entangled with the fundamental fabric of the universe, linked to the quantum field that permeates all of reality. If this is true, then consciousness could be non-local, existing not only in the brain but also across space and time, as part of the deeper quantum nature of reality. Brain-bound versus universal consciousness. The central paradox of consciousness is the question of whether it is local, confined to the brain and the nervous system, or whether it is non-local, connected to the broader universe and part of a cosmic mind. On one hand, we have the brain-bound consciousness, which holds that the mind and awareness are products of neural activity, confined to the body and limited by its biological processes. In this view, consciousness is finite when the brain dies. Consciousness ends. On the other hand, we have the possibility of universal consciousness, where the mind is not confined to the brain but is an extension of a greater, non-local consciousness that is entangled with the universe. In this view, consciousness is infinite and eternal, capable of transcending the physical body and merging with the cosmic consciousness that spans the universe. Death in this context is not the end of consciousness, but a transition, a return to the universal mind. This paradox raises profound questions about the nature of reality, the self, and the universe. If consciousness is non-local, what does that say about the nature of individuality and the continuity of the self? Are we truly separate, individual beings, or are we simply manifestations of a larger, interconnected mind temporarily experiencing life from a single point of view, beyond the brain, into the cosmos. As we contemplate the paradox of consciousness, we are faced with the possibility that the mind is not simply a byproduct of the brain, but a non-local phenomenon connected to the very fabric of the universe. The more we explore the strange world of quantum mechanics, the more we see that consciousness might not be confined to the brain at all. Instead, it may be part of a larger universal consciousness, deeply entangled with the quantum field that permeates all of reality. This non-local view of consciousness suggests that the universe itself may be conscious, and that each individual mind is a temporary manifestation of this larger cosmic awareness. Death, in this view, is not the end of consciousness, but a transformation, a shift from the individual to the universal. The mind, like quantum particles, might continue to exist in some form, connected to the infinite, entangled with the cosmos. The mystery of consciousness remains unsolved, but the possibility that we are part of a much greater, non-local mind offers a profound new way to think about the nature of life, death, and existence. Perhaps in the end, we are not just a collection of neurons, but something much more cosmic, interconnected, and eternal. Quantum entanglement, the weirdness of the universe. Imagine two particles, once in contact with one another, are now separated by vast distances, perhaps even light years apart. And yet, in the instant one particle changes, the other changes too, as if they were still connected by an invisible thread. No matter how far they are apart, their states are linked, their fates intertwined. This is the phenomenon of quantum entanglement, one of the most mind-bending and paradoxical aspects of quantum mechanics, where particles can remain entangled, their behaviors correlated, even across vast stretches of space-time. In classical physics, objects are understood to be separate entities, acting independently of one another. If you push one object, it moves based on its own properties, independent of any other object. This classical view of separate objects is simple, intuitive, and it aligns with the everyday experiences we have of the world. But in the quantum realm, the rules are radically different. Quantum entanglement defies the classical idea of separation, suggesting instead that everything in the universe might be intricately connected, even at a distance. This leads to one of the most fascinating and profound questions in the study of consciousness. Could the processes in the brain, the very thoughts and experiences that make up our awareness, involve quantum entanglement? Could our minds be non-local, entangled with the cosmos itself? In this section, we'll explore the strange world of quantum entanglement, explaining how it works, why it's so baffling, and what it might mean for our understanding of the mind and consciousness. We'll delve into how this phenomenon challenges the classical view of the universe and consider the possibility that, just as particles can become entangled, perhaps our consciousness could also be part of an interconnected, non-local reality. The basics of quantum entanglement. At the heart of quantum mechanics lies entanglement, a phenomenon that Albert Einstein famously referred to as spooky action at a distance. Entanglement occurs when two or more quantum particles, such as photons, electrons, or atoms, become linked, their states intertwined in such a way that the state of one particle directly affects the state of the other, no matter how far apart they are. For example, consider two particles, A and B, that are entangled. If you measure the state of particle A, say its spin or polarization, the state of particle B will instantly adjust to match, even if particle B is on the other side of the universe. This instantaneous connection seems to violate the principle of locality, which holds that information or influence cannot travel faster than the speed of light. In the classical world, such behavior makes no sense. How could two particles separated by light years instantly influence each other? Yet when quantum particles become entangled, the connection between them is real, not just theoretical. This phenomenon has been experimentally verified. Most famously in Bell's theorem experiments which showed that the predictions of quantum mechanics regarding entanglement are accurate. Entanglement challenges our intuitive understanding of space, time, and causality. It suggests that, on the quantum scale, objects are not isolated but are instead part of a larger, interconnected whole. This profound realization is at the heart of what makes quantum mechanics so strange and fascinating. The view of separate objects before quantum mechanics revolutionized our understanding of the universe. Classical physics governed the way we thought about the world. In classical physics, objects are separate and distinct, each existing within its own space and time. The universe was like a giant machine, with each part functioning independently and moving according to the laws of deterministic motion. For example, when you throw a ball, you know that its trajectory is determined by the force you exert and the gravitational pull of the Earth. The ball's motion is a predictable, linear response to these forces, and its behavior is completely separate from any other object. The world, in classical physics, is made up of isolated systems that operate independently of each other. This view of separate objects works well for everyday objects in our macroscopic world. But when you move to the microscopic world of atoms and subatomic particles, the rules change dramatically. In the quantum world, particles don't behave like isolated objects. They behave like interconnected systems that can influence each other across vast distances. Connectedness across space-time, quantum entanglement turns the classical view of separation on its head. It shows that at the quantum level, particles are not isolated but are part of an interconnected web of reality. When particles become entangled, their states are linked in such a way that they are no longer independent. Instead, they form a unified system where the state of one particle can directly influence the state of another, regardless of the distance between them. This concept challenges the classical notion of locality, the idea that objects can only be influenced by their immediate surroundings. In the quantum realm, particles do not follow the rules of locality. Instead, they follow the rules of non-locality, where connections between particles can be established even over vast distances. The universe, at the quantum level, seems to be a web of interconnections, with each particle connected to every other particle, no matter how far apart they may be. This radical idea of non-locality suggests that everything in the universe could be entangled in some way, creating an interconnected holistic reality. If particles can be entangled across space-time, could the mind and consciousness be similarly entangled, with each individual mind being part of a larger, non-local consciousness? Could our minds be non-local? Given the strange and counterintuitive nature of quantum entanglement, it's natural to wonder whether this phenomenon might play a role in consciousness itself. Could the processes that give rise to our thoughts and awareness involve quantum entanglement, making our minds part of a larger non-local consciousness? Is it possible that our individual minds are not truly isolated but entangled with a greater cosmic consciousness that transcends space and time? Some researchers have proposed that the brain, with its vast network of neurons and synaptic connections, might be capable of supporting quantum processes that could give rise to non-local consciousness. The theory of quantum consciousness, popularized by physicists like Roger Penrose and Stuart Hameroff, suggests that quantum coherence, the idea that particles maintain a unified state over time, could play a role in the brain's ability to process information and generate conscious experience. According to this theory, the brain might function as a quantum computer, processing information in ways that go beyond classical neural activity. In this view, consciousness is not confined to the brain's biological processes, but is part of a larger, interconnected quantum system. Just as quantum entanglement links particles across vast distances, our consciousness might be linked to the broader quantum field, forming part of a universal cosmic consciousness. Consciousness is non-local. If the processes of consciousness involve quantum entanglement, It suggests a radically new view of the mind. Instead of being brain-bound and isolated within the confines of the skull, our consciousness might be part of a larger non-local system, entangled with the quantum fabric of the universe. This view suggests that we are not isolated individuals, but interconnected with everything in existence, connected to a greater cosmic consciousness that spans the universe. The idea of a non-local consciousness has profound implications for how we think about the nature of self and identity. If consciousness is entangled with the quantum field, then the self is not confined to the body, but part of a greater, interconnected system. This would imply that death is not the end of consciousness, but a transition, a shift in the entanglement of the mind from the physical body to the larger quantum reality. The strange and infinite connection quantum entanglement reveals a universe that is deeply interconnected, where particles are not isolated but part of a larger web of reality. This insight challenges the classical view of separate objects and suggests that the universe, at its core, is an interconnected whole. Could the brain and consciousness operate in the same way, with our minds being part of this vast, non-local system? As we look at the possibility of quantum entanglement playing a role in consciousness, we are faced with a profound question. Could our minds be non-local, connected not just to our bodies, but to a larger universal consciousness that transcends space and time? The strangeness of quantum physics offers us a glimpse into a reality that is far more interconnected and mysterious than we could have ever imagined, one where consciousness is not limited to the brain, but is entangled with the very fabric of the cosmos itself. The brain, a classical information processor. When we think of the mind and consciousness, we often picture the brain as the command center of all thought, perception, and self-awareness. From a biological standpoint, the brain is not just an organ. It is a highly sophisticated information processor, a system of neurons firing electrical impulses, transmitting data across complex networks and generating our subjective experience. According to this classical view, consciousness arises as an emergent property of this biological machine. Every thought, every sensation, every moment of awareness is the result of intricate information processing within the brain. The brain is composed of approximately 86 billion neurons, each connected by synapses, tiny junctions where electrical signals are passed from one neuron to the next. Neurons form vast neural networks, and these networks communicate by firing electrical signals that propagate across the brain's circuitry. This classical model of the brain as a biological computer processing information in response to stimuli has been the foundation of neuroscience for centuries. In this section, we will delve into the classical view of the brain as an information processing system. We will explore the role of neurons, synapses, and neural networks in shaping our experience of consciousness from a biological and computational standpoint. Establishing this baseline will allow us to understand the traditional view of the mind, setting the stage for the more speculative exploration of quantum processes in the brain. Is the brain simply a classical machine, or could quantum mechanics be playing a role in the very foundation of consciousness? The brain, a biological information processor. The classical model of the brain views it as an information processor, a highly complex system capable of taking in sensory input, processing it, and generating appropriate responses. The brain receives data through the sensory organs, eyes, ears, skin, etc., and translates this input into electrical signals that are processed in different regions of the brain. These signals are transmitted through an intricate network of neurons, which are the building blocks of the nervous system. At its most basic level, the brain functions through the transmission of electrical signals between neurons. When a neuron receives a signal from another neuron, it becomes excited, generating an action potential, a brief electrical impulse that travels down the axon of the neuron. At the end of the axon, the signal is passed across the synapse to the next neuron via chemical neurotransmitters. These neurotransmitters bind to receptors on the next neuron, initiating a new electrical impulse. This process repeats, creating a vast, interconnected web of signals that allow for information to be transmitted throughout the brain. This system of neural communication forms the foundation of the brain's ability to process information. It allows us to perceive the world, make decisions, store memories, and experience emotions. It is this biological machinery that is thought to underlie the experience of consciousness, our ability to be aware of ourselves, our surroundings, and our thoughts. Neural networks and the emergence of consciousness neurons do not operate in isolation. Instead, they form neural networks with many neurons working together to process information. These networks are organized into circuits that handle different types of information. For example, the visual cortex processes visual input, the auditory cortex processes sound, and the prefrontal cortex is involved in higher-order functions such as decision-making, reasoning, and self-awareness. The brain's ability to generate complex thought and consciousness arises from the interaction of these neural networks. Each neural circuit plays a role in processing specific types of information, and the combined activity of these circuits gives rise to our cognitive functions. Perception, memory, emotion, and thought are all the result of neural activity within the brain. As these networks of neurons fire together, they form patterns of activity that correspond to our experiences. One important feature of these neural networks is plasticity, the brain's ability to reorganize and form new connections in response to learning and experience. This plasticity allows the brain to adapt to new information, and it plays a crucial role in the process of learning and memory. The brain is constantly reshaping itself, forming new connections as we process information and interact with the world. From this classical perspective, consciousness is seen as an emergent property of the brain's information processing. In this view, consciousness is not a separate, mystical entity, but is instead the result of complex interactions between neurons and neural networks. The information processed by the brain gives rise to the subjective experience of awareness, our ability to perceive, think, and feel. The brain. As a computational system, in many ways the brain can be likened to a biological computer. It receives input, sensory data, processes that information through complex circuits, and then generates output, thoughts, actions, and responses. This view treats the brain as a highly efficient computational system where each neuron and synapse performs a specific function in the process of information processing. This computational analogy has been further developed in the field of cognitive science, where the brain is often modeled as a symbolic processing system. Just as a computer processes binary code, ones and zeros, the brain processes information through neural signals, creating patterns that correspond to our mental states. Cognitive models of the brain often break down cognitive functions into discrete tasks, much like how a computer executes specific instructions to perform a task. From this computational perspective, consciousness arises as a byproduct of the brain's complex information processing. The brain processes information in response to external stimuli, and this processing gives rise to the mental states that we experience: thoughts, emotions, perceptions, and self-awareness. In this sense, consciousness is viewed as a computational output of the brain's internal processes. The classical brain versus quantum consciousness. While the classical model of the brain as an information processor has been highly successful in explaining many aspects of cognition and consciousness, it raises important questions. If the brain is purely a biological and computational machine, then how does it give rise to subjective experience? How do thoughts and feelings emerge from the firing of neurons? This hard problem of consciousness, as it has been called, remains one of the most profound mysteries in neuroscience and philosophy. This brings us to the question, could quantum mechanics play a role in consciousness? Could the classical information processing of the brain be influenced by quantum processes, allowing for a deeper, more complex interaction between the brain and the universe? Some scientists and theorists suggest that the brain may not be a purely classical machine, but might involve quantum effects that play a crucial role in generating consciousness. Quantum mechanics operates in a realm of probability, entanglement, and superposition, where particles can exist in multiple states at once, and their behavior can be influenced instantaneously across vast distances. Could the brain, with its highly complex neural networks, be capable of quantum coherence, where the principles of quantum mechanics influence the way information is processed? Could quantum processes be the missing link that explains how subjective experience arises from the brain's information processing? The brain, as a classical versus quantum system. The speculative leap. While the classical model of the brain offers a solid foundation for understanding many aspects of consciousness, it does not fully account for the mysteries of the mind, the way in which subjectivity and self-awareness arise from neural activity. This is where the speculative idea of quantum processes within the brain comes into play. Some researchers, like Roger Penrose and Stuart Hameroff, have proposed that quantum coherence in microtubules within neurons could give rise to consciousness, suggesting that the brain is not just a classical computer, but a quantum one. The question of whether the brain can incorporate quantum effects remains highly speculative. However, it opens up the possibility that consciousness may not be a purely classical process, but one that incorporates both biological and quantum elements. In this view, the brain might function as a quantum computer, capable of processing information not just through classical neural networks, but through quantum entanglement and superposition. The brain as a classical machine for now. The classical view of the brain as a biological information processor remains the most widely accepted framework for understanding consciousness. It provides a detailed and scientifically grounded model for how the brain processes information, forms memories, and generates awareness. However, this view also faces significant challenges, particularly when it comes to explaining the subjective experience of consciousness. As we look ahead, the possibility of quantum processes in the brain offers an intriguing avenue of exploration. While the classical view has served us well in many respects, the quantum mind hypothesis suggests that there may be more to consciousness than meets the eye, a deeper, more mysterious interaction between the brain and the quantum world that we are only beginning to understand. As we move forward, it will be essential to balance the well-established classical understanding of the brain with the speculative possibility of quantum processes. The true nature of consciousness may lie at the intersection of both a profound blend of biology and quantum mechanics, one that promises to unlock some of the deepest mysteries of the mind and the universe itself. The case for quantum consciousness. Can the brain harness quantum effects? What if consciousness is not just a byproduct of classical biological processes in the brain? What if the very fabric of reality, the quantum world, with its mysterious superpositions, entanglements, and probabilities, is not merely an abstract concept, but a crucial part of how we experience awareness, thought, and selfhood? What if the brain is more than a biological computer processing information with the laws of classical physics, and instead it's a quantum information processor able to harness the strange, non-local effects of quantum mechanics to generate consciousness? In this section, we will explore one of the most speculative and exciting ideas in the study of consciousness, the possibility that the brain might harness quantum effects. We'll delve into the Orch-OR theory, orchestrated objective reduction, proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff, which suggests that tiny structures inside our neurons called microtubules could be the key to understanding how the brain could tap into the quantum realm. According to this theory, microtubules could serve as sites for quantum computation, and this quantum process might play a role in the very nature of consciousness itself. As we explore the theory of quantum consciousness, we will contrast the classical view of the brain as a purely biological information processor with the quantum view that suggests the brain operates not only at the classical level but at the quantum level as well, integrating quantum effects into biological processes that could explain the phenomenon of consciousness. The classical brain, a biological information processor. The classical view of the brain holds that consciousness arises from the biological and computational processes that occur in the brain's neural networks. As we've seen, the brain is a highly complex information processing system where billions of neurons communicate with each other via synapses. The brain's processing of information is viewed as entirely classical, a set of deterministic, mechanical processes based on the firing of neurons, chemical reactions, and electrical impulses. In this model, consciousness is often seen as an emergent property of these biological processes. It is the product of complex interactions within neural circuits, and it relies on classical physics, the laws of deterministic interactions that govern the behavior of everyday objects. The brain is seen as a biological machine, where the activity of neurons and synapses gives rise to thought, emotion, memory, and self-awareness. This view works well for explaining many aspects of brain function and cognition. However, when it comes to explaining subjective experience, the feeling of being conscious, of being aware of our thoughts and surroundings, this classical model falls short. Quantum effects in the brain. This brings us to the quantum hypothesis of consciousness, a bold and speculative theory that suggests quantum mechanics might be at the heart of the brain's ability to generate consciousness. Quantum mechanics, as we've seen, operates according to very different rules than classical physics. In the quantum world, particles don't exist in definite states until they are observed. They exist in a superposition, simultaneously occupying multiple possibilities. Furthermore, particles can become entangled so that the state of one particle instantaneously affects the state of another, no matter how far apart they are. This non-local feature of quantum mechanics challenges our classical understanding of space and time, suggesting that reality might be interconnected at a level we cannot perceive directly. What if the brain is not simply processing information in a classical deterministic manner but is also capable of utilizing these quantum effects? What if the very phenomenon of consciousness arises from the interaction of quantum processes within the brain's neural network? This idea is at the core of the Orch-OR theory, a theory that posits quantum computations occurring within the microtubules of neurons might be responsible for generating conscious experience. The quantum consciousness theory, the Orch-OR theory, orchestrated objective reduction, was first proposed by physicist Roger Penrose and anesthesiologist Stuart Hameroff in the 1990s. The theory combines principles of quantum mechanics with neurobiology to explain how consciousness might arise from quantum processes within the brain. According to Penrose and Hameroff, the key to understanding consciousness lies in the microtubules, the tiny, tube-like structures that are found within the cells of neurons. Microtubules are part of the cytoskeleton of the neuron, providing structural support and helping with cellular processes like division and transport, but Penrose and Hameroff suggest that microtubules could also act as quantum computational devices. They believe that at the quantum level, the microtubules might support quantum coherence, allowing quantum information to be processed within the brain. These quantum states could be orchestrated and reduced into classical states, giving rise to conscious experience. At the heart of Orch-OR is the idea of objective reduction. Penrose theorizes that when a quantum system reaches a certain threshold of complexity, it will collapse into a definite state, an event he calls objective reduction. This collapse, or reduction, could be the moment at which consciousness arises, as the quantum information processed in the microtubules is brought into the classical realm of experience. In this view, consciousness is not a continuous stream of neural activity, but a series of quantum collapses that give rise to discrete, conscious moments. Quantum computation in the brain, if the microtubules in neurons are indeed capable of supporting quantum coherence, the implications for consciousness are profound. The brain could be operating as a quantum computer, processing information not just in the classical sense, but through the quantum phenomena of superposition and entanglement. This would allow the brain to process information in ways that go beyond the limits of classical computing, making consciousness not just an emergent property of neural activity, but a phenomenon that arises from the quantum realm. In this view, quantum coherence could allow the brain to process information in parallel, entangling different states of the brain's neurons across space and time, creating an interconnected web of awareness. This quantum processing might help explain the unity of consciousness, how we experience a continuous, integrated sense of self, despite the complexity and fragmentation of the information we receive. Brain as classical as quantum information. Processor. The contrast between the brain as a purely classical information processor and the brain as a quantum information processor is striking. The classical view holds that the brain operates like a biological computer, processing information through classical neural activity. The mind, in this view, is nothing more than the product of complex interactions between neurons, synapses, and chemical processes. On the other hand, the quantum view of consciousness, as proposed by the Orch-OR theory, suggests that the brain operates not just at the classical level but also at the quantum level. In this view, consciousness arises from quantum computations within the microtubules of neurons, enabling the brain to process information in ways that classical biology cannot explain. If quantum effects are involved, then consciousness could be far more complex and interconnected than we ever imagined, transcending the limits of classical thought. This shift in perspective raises profound questions. Is the mind truly local, confined to the brain and the body? Or could consciousness be non-local, connected to a broader quantum field that permeates the universe? Could the quantum brain, with its ability to process information in a non-local and parallel fashion, be tapping into a greater universal consciousness? Quantum consciousness and the nature of the mind, as we explore the Orch-OR theory and the idea that quantum effects could play a role in the brain's information processing, we are confronted with a revolutionary possibility. If the brain can harness quantum effects, it could be a quantum computer capable of accessing deeper, non-local levels of consciousness. Consciousness itself may not just emerge from classical neural processes, but could be the result of quantum coherence, entanglement, and superposition within the brain's neural networks. This speculative idea opens up new frontiers in the study of the mind and consciousness. If quantum mechanics is indeed at play in the brain, then consciousness might be far more complex, interconnected, and mysterious than we ever thought. It suggests that we are not merely biological machines, but quantum beings, entangled with the very fabric of the universe. The implications of quantum consciousness are profound, challenging our understanding of the mind, the brain, and the nature of reality itself. As we continue to explore the possibility of quantum processes in the brain, we are left with more questions than answers, but also with a sense of awe and wonder at the mysteries that lie ahead. Non-locality, a hidden dimension of reality. Imagine that two particles, separated by vast distances, perhaps even light years apart, can instantaneously influence each other's states, even though no signal or force is physically traveling between them. This instantaneous connection defies our understanding of space and time. In classical physics, objects are thought to interact only through local interactions, meaning they are affected by forces or information that exist in their immediate surroundings. But in the quantum world, something far more profound is at play. Non-locality suggests that information, influence, or correlation can be shared across space and time, without any clear, direct connection. It's a phenomenon that challenges everything we thought we knew about the nature of reality. What if consciousness, the very fabric of our awareness, is not confined to the brain, a local, biological machine, but instead is non-local, extending across space-time and connected to the quantum field that underpins all of reality? Could our thoughts, feelings, and experiences be linked to a deeper, non-local consciousness entangled with the fabric of the universe itself? In this section, we will explore the concept of non-locality, a quantum phenomenon that implies a deeper level of connectedness in the universe, one that transcends the limitations of space and time. We will examine how this idea challenges the classical view of local interactions and explore the possibility that consciousness itself could be a non-local phenomenon connected to the quantum fabric of reality. By the end, we'll see how non-locality could provide a radically new perspective on the nature of consciousness and the mind. The classical view: local interactions and the limits of space-time. In classical physics, the idea of local interactions governs how we understand the world. If you push a ball, it moves in response to the force you applied, and the ball's movement is directly influenced by nearby objects or forces. The classical view holds that objects and forces interact within a local space-time, that is, objects are affected by other objects only when they are in close proximity, and any influence or information is transmitted through some physical medium, such as light or sound waves, within a certain distance. This view works perfectly well in the macroscopic world, the world we see and experience every day. It explains how objects in our environment move and interact, and it's the basis for much of classical Newtonian physics. Everything happens locally, objects are separate, and their interactions occur within defined spatial boundaries. In the idea that events are bound by space and time, that the location of an object and the moment in time matter, is fundamental to our understanding of the universe. However, when we step into the quantum realm, these classical notions begin to break down. At the scale of atoms and subatomic particles, things don't behave the way we expect. Particles that were once thought to be separate, isolated entities are now understood to be capable of instantaneous influence over one another, regardless of distance. This is the essence of quantum non-locality, the idea that events can be correlated across space and time without any obvious or direct connection between the objects involved. Non-locality in quantum mechanics, entanglement, and the nature of reality. At the heart of quantum mechanics lies the concept of non-locality, which suggests that particles can become entangled, their properties and states linked in such a way that the behavior of one particle is instantly reflected in the behavior of another, no matter how far apart they are. This phenomenon is known as quantum entanglement. In the classic example of quantum entanglement, two particles are created together in such a way that their properties, such as spin or polarization, are linked. If one particle is measured and its state is determined, the other particle's state will instantaneously be determined, even if it is light years away. This connection is not limited by the speed of light, which is the universal speed limit in classical physics. Instead, entangled particles share a kind of instantaneous connection that is outside the realm of classical space-time. This non-local behavior challenges our understanding of how information and influence can be transferred. In the classical world, we assume that any influence or signal must travel through space-time, moving at a finite speed. But in quantum mechanics, this assumption is upended. Particles can affect each other across vast distances without any apparent physical medium through which information is transmitted. The question this raises is profound. Could the mind, our consciousness, function in a similar way? Could consciousness itself be non-local, connected to the very fabric of the quantum field, and not confined to the brain or body? non-local consciousness, could the mind be part of a universal quantum field? If quantum entanglement suggests that information and influence can be shared across space-time in ways we don't yet fully understand, could the brain's processes also operate in a non-local way? Could consciousness itself be connected to a larger, non-local field linked not just to the brain, but to the entire quantum system that underpins the universe? Some theories in quantum consciousness propose that consciousness is not confined to the brain as a local biological phenomenon, but is part of a greater universal field. In this view, the brain might serve as a quantum antenna, tuning into and interacting with the quantum fabric of reality, but the consciousness that arises from it is not strictly local. It is part of an interconnected, non-local awareness that transcends the physical body. Just as quantum particles can be entangled and exhibit non-local behavior, could individual consciousnesses also be part of a larger, non-local system of awareness? If consciousness can be thought of as an information processing phenomenon, then perhaps it is not just a biological process, but also a quantum one that is part of a vast, interconnected network that extends beyond the brain and body, reaching into the quantum field that permeates the universe. This theory aligns with ideas from panpsychism, which suggests that consciousness is not just a byproduct of complex neural networks, but is instead a fundamental property of the universe, present in all matter, from the smallest particles to the largest galaxies. If consciousness is truly a universal phenomenon, then it might not be confined to the brain at all, but be non-local, extending throughout the cosmos and interwoven with the fabric of space-time. Non-local consciousness and the holographic universe. The idea of non-local consciousness is closely tied to the concept of the holographic universe, a theory that suggests the entire universe is a projection of information encoded on a two-dimensional surface. In this view, the physical universe we experience is just a holographic image, a projection that arises from deeper, non-local information encoded at the boundaries of space-time. If the universe is indeed holographic, then consciousness might not be a localized phenomenon at all. Instead, it could be a projection of non-local information, an awareness that arises from the interaction between the brain's quantum processes and the greater holographic field. In this context, death might not be the end of consciousness, but a return to the non-local field where consciousness merges back into the quantum fabric of reality. This theory suggests that our individual consciousnesses are not separate, isolated entities, but part of a greater universal consciousness connected to the quantum field and the holographic projection of the universe. The brain, rather than being a purely classical information processor, might be a quantum interface that tunes into this deeper, non-local reality. Local versus non-local, the nature of information and consciousness. The contrast between local and non-local interactions is central to understanding the nature of consciousness. In the classical view, the brain is a local system, with information processed through neurons and synapses operating within the boundaries of the body and the physical world. But quantum mechanics introduces the possibility that consciousness might be part of a much larger, non-local system, one that transcends the brain and is connected to the deeper fabric of reality. If consciousness is non-local, it would imply that the mind is not confined to the brain, but is instead a part of a vast, interconnected system. This non-local consciousness would be capable of tapping into information and awareness from the quantum field, existing beyond the confines of space and time. In this view, consciousness is not an isolated process, but a shared phenomenon, one that connects us to the universe itself. Conclusion: the quantum web of consciousness. The concept of non-locality suggests that the universe is far more interconnected than we ever realized. At the quantum level, particles and information are linked across vast distances, and this non-local connection challenges our classical understanding of space and time. Could consciousness too be non-local, extending beyond the brain and connected to a greater, universal field? As we continue to explore the nature of consciousness, it becomes clear that non-locality plays a key role in understanding how the mind works, how it interacts with the world, and how it might transcend the limitations of the physical body. Whether through quantum entanglement, the holographic universe, or non-local information transfer, the mind may not be the isolated, brain-bound phenomenon we once thought, but a non-local connection to the very fabric of reality itself. Quantum brain dynamics, entangled neurons and non-local consciousness. What if the brain, that remarkable organ we've always thought of as a biological information processor, operates not just according to the laws of classical physics, but also according to the strange, non-intuitive rules of quantum mechanics? What if the very neurons and synapses that form the foundation of our thoughts and actions are capable of behaving in a quantum manner, capable of becoming entangled with one another and generating quantum coherence that could explain the deepest mysteries of consciousness? At the heart of quantum mechanics is the idea that particles can be in multiple states at once, superposition, and can be entangled, instantaneously connected over vast distances. Could the brain's neurons, those tiny cells that transmit information throughout the body, be quantum computers of sorts? Could the processes of memory, decision-making, and perception be influenced by quantum effects such as entanglement and coherence? In this section, we will explore this fascinating hypothesis that the brain's neurons and synapses may indeed function in a quantum manner, allowing the brain to exhibit entangled behavior and operate as a quantum system. We'll delve into the research suggesting that quantum coherence might occur within the brain's microtubules, and we'll examine how this quantum framework could potentially help explain non-local consciousness, the idea that consciousness is not confined to the brain, but is entangled with the greater quantum field. A classical information processor. For much of our understanding, the brain has been viewed through the lens of classical physics. The brain is a biological organ made up of neurons, the basic cells responsible for transmitting information throughout the nervous system. Neurons communicate with each other through synapses, where electrical signals are passed across tiny gaps between cells. This process forms the foundation for information processing in the brain, from sensory input to motor function, from perception to higher cognitive processes. In the classical view, the brain's function is understood as an intricate network of electrical and chemical signals that form a deterministic system, one in which every thought, feeling, or action can be traced back to the activity of neurons firing and synapses transmitting signals. The brain, in this view, is analogous to a biological computer, processing information in a linear, deterministic way, governed by the laws of classical mechanics. However, as we've seen, this classical model falls short in explaining the subjective experience of consciousness. The brain's information processing may account for the mechanics of perception and action, but how does the inner experience of awareness arise from these processes? This question, the so-called hard problem of consciousness, continues to challenge scientists and philosophers alike. The key to consciousness. Quantum mechanics, with its strange and counterintuitive principles, might offer a new way to understand consciousness. At the quantum level, particles do not behave like solid objects. Instead, they exist in superposition, existing in multiple states simultaneously until they are measured or observed. Additionally, quantum particles can become entangled, meaning that the state of one particle can instantaneously affect the state of another, regardless of the distance between them. This concept of non-locality has profound implications for how we understand the nature of reality itself. Could the brain, with its complex network of neurons and synapses, also exhibit quantum effects? Could the mind be part of the quantum field, capable of interacting with non-local information in ways that transcend the classical understanding of brain function? This is where the hypothesis of quantum brain dynamics comes into play, the idea that the brain might not only operate classically, but also incorporate quantum processes into its function. Quantum coherence in the brain. One of the most intriguing aspects of this hypothesis comes from the study of microtubules, tiny tube-like structures found inside the neurons. Microtubules are part of the cytoskeleton of cells, providing structural support and helping with cellular processes like division and transport. But some researchers, particularly physicist Roger Penrose and anesthesiologist Stuart Hameroff, have proposed that microtubules could also support quantum coherence. The idea that quantum effects like superposition and entanglement could occur within the brain's neural networks. According to Penrose and Hameroff's Orch-OR theory, orchestrated objective reduction, microtubules within neurons might be able to hold quantum states for short periods of time, allowing quantum coherence to influence the brain's processes. In this theory, quantum computation might occur within the microtubules, with information being processed in ways that transcend classical neural processing. This quantum processing could be the key to explaining consciousness, giving rise to the subjective experience of awareness and selfhood. The hypothesis suggests that quantum entanglement could link neurons together in a way that allows the brain to process information non-locally, connecting different parts of the brain instantaneously, regardless of distance. This would allow the brain to tap into non-local information, much like how quantum particles can become entangled and share information instantaneously. If consciousness arises from quantum effects within the brain, it could explain how the mind feels unified, how we experience a continuous sense of self, despite the fragmented and disparate sensory inputs we receive. Entanglement and non-local consciousness. The idea that the brain might harness quantum entanglement raises the question, could our consciousness be non-local, linked not just to the brain, but to a greater quantum field that permeates all of reality? If quantum mechanics allows particles to be entangled, then could our minds also be part of a larger, interconnected web of consciousness? In this view, consciousness would not be confined to the brain, but would instead be entangled with the quantum field that spans the universe. Just as entangled particles can influence each other instantaneously across vast distances, perhaps our minds too are entangled with the greater cosmic field. Our thoughts, memories, and experiences might be linked not just within the brain, but across space and time, forming part of a larger, universal consciousness. This idea of non-local consciousness aligns with theories like panpsychism, which suggests that consciousness is not limited to human beings or animals, but is a fundamental property of all matter. If the brain functions as a quantum information processor, then the self, our subjective awareness, might be part of this larger quantum field of consciousness, entangled with the universe itself. How quantum effects might manifest in the brain. Quantum processes are indeed involved in brain function. What might this mean for memory, decision-making, and perception? These complex cognitive functions are thought to arise from the activity of neurons and neural networks, but could quantum coherence play a role in their integration and processing? In memory, for example, quantum effects might help explain the interconnectedness of memories and experiences. If the brain is a quantum system, memories could be stored and accessed in a non-local fashion, linked across time and space in ways that classical systems cannot account for. Quantum coherence could allow memories to be retrieved and integrated in a way that is not confined to local circuits in the brain, but instead involves a larger quantum field of interconnected awareness. Decision-making could also be influenced by quantum processes. Classical models of decision-making focus on how neurons process information and make choices based on sensory input and prior experience. But in a quantum brain, entanglement might allow decisions to be made in a parallel and non-local manner, where different possibilities are superposed and the brain collapses these possibilities into a coherent decision. Perception too might be influenced by quantum coherence. Our perception of the world is not just a passive reflection of sensory data, it involves the active processing of information, integrating our past experiences with current stimuli. If the brain is operating as a quantum computer, then perception might involve non-local integration of information, allowing for a deeper, more holistic experience of the world. Classical brain versus quantum brain. A new paradigm, the contrast between the classical brain viewed as a purely biological information processor and the quantum brain capable of harnessing the strange properties of quantum mechanics is profound. The classical view holds that consciousness arises from the neural activity of the brain, while the quantum view suggests that consciousness might also be the result of quantum coherence, entanglement, and superposition. This new paradigm invites us to reconsider the very nature of consciousness. If the brain is not just a classical machine but a quantum information processor, then consciousness might not be confined to the brain's physical structure, but instead could be non-local, interconnected with the quantum fabric of the universe. In this view, the brain's role is not just to process information locally, but to tap into the quantum field, integrating quantum information across space and time, a quantum leap in understanding consciousness. As we explore the possibility of quantum brain dynamics, we begin to see the brain not just as a biological computer, but as a complex quantum system capable of processing information in ways that go beyond classical physics. Quantum coherence in microtubules might allow the brain to harness entanglement and superposition, giving rise to the subjective experience of consciousness. If quantum processes are indeed involved in consciousness, then the mind might not be confined to the brain, but could be part of a larger, non-local consciousness linked to the quantum field of the universe. This opens up new possibilities for understanding the nature of self, memory, perception, and the universe itself, suggesting that consciousness might be far more interconnected and mysterious than we ever imagined. The quantum mind and the nature of reality. What if the mind, that most intimate part of our experience, is not confined to the brain, not limited to the physical boundaries of our bodies? What if, instead, the mind is a conduit for information that connects us to a deeper, more profound level of reality, one that stretches beyond space and time? Could consciousness as we know it be a reflection of the quantum fabric of the universe, entangled with the very nature of existence itself? This is a question that blurs the lines between science, philosophy, and metaphysics, one that forces us to reconsider our place in the cosmos. If the brain is indeed a quantum processor, as we've explored, then perhaps consciousness is not confined to the brain's neural network, but instead reaches out to the universe, tapping into the deeper, non-local dimensions of reality. In this view, the boundary between self and universe becomes increasingly fluid, with consciousness extending beyond the body, becoming part of a greater whole. In this section, we will connect the potential for quantum processes in the brain to broader philosophical questions about the nature of reality. We will examine the implications of a quantum mind, where the mind is no longer an isolated, self-contained entity, but an open system connected to the quantum fabric of the universe. This quantum view of consciousness challenges the traditional materialist perspective, which holds that the mind is simply a product of the brain's biological processes. Could it be that far from being confined to the brain, our minds are open systems, interconnected with the universe in ways that we have yet to fully understand? The mind as a self-contained entity. In the materialist view, which has dominated much of modern neuroscience and philosophy, the mind is a product of the brain. According to this perspective, consciousness arises from the complex interactions of neurons, synapses, and neurotransmitters. The brain is seen as a biological machine, processing information and generating thoughts, feelings, and experiences. This view assumes that the mind is self-contained, it exists within the brain, and is entirely dependent on the physical structure and function of the nervous system. In this model, consciousness is a local phenomenon, limited to the brain and the body. The mind, like any other organ, is thought to emerge from the physical processes that occur within it. Thoughts and emotions arise from the activity of neurons firing and communicating with each other. The self is seen as an emergent property of these neural networks, a byproduct of the brain's ability to process complex information. For many materialists, this view works well in explaining much of human cognition and behavior. The brain's ability to process sensory input, form memories, and regulate bodily functions is well documented and deeply understood. However, there are still profound questions that remain unanswered. Consciousness, as we experience it, our sense of self-awareness, our ability to reflect on our own thoughts, our rich inner lives, is not easily explained by the firing of neurons alone. This is where the hard problem of consciousness comes into play. How do physical processes in the brain give rise to subjective experience? How do neural patterns of activity translate into the vivid inner experience of thought, emotion, and awareness? The materialist view, while powerful in explaining many aspects of brain function, falls short in addressing the most profound question: why are we conscious at all? A conduit to the universe. Enter the quantum mind hypothesis, which suggests that quantum mechanics may play a crucial role in the generation of consciousness. Quantum mechanics, the branch of physics that governs the behavior of particles on the smallest scales, is full of mysteries that challenge our classical understanding of reality. In the quantum world, particles exist in superposition, meaning they can be in multiple states at once, and they can be entangled, meaning the state of one particle can instantaneously influence the state of another, regardless of distance. If the brain operates as a quantum system, as proposed by Penrose and Hameroff in their Orch-OR theory, then consciousness could be seen as a non-local phenomenon, extending beyond the brain and body, connected to the quantum fabric of reality. In this view, the mind is not a self-contained entity, but a conduit for information that flows between the brain, the body, and the universe. The quantum mind hypothesis suggests that the brain's microtubules, the tiny, tube-like structures within neurons, could function as sites for quantum coherence, allowing quantum information to be processed and integrated into the brain's neural activity. This quantum processing could enable the brain to tap into non-local information, drawing on the quantum field that spans the universe. If this is the case, then consciousness is not confined to the brain, but is part of a much greater, interconnected reality. Self and universe. As one, if consciousness is truly non-local, the boundaries between self and universe become increasingly blurred. In this view, the mind is not a separate, isolated entity, but part of a vast, interconnected quantum system that links the brain to the entire cosmos. The self, as we experience it, may not be the fixed, self-contained identity we often assume it to be. Instead, our sense of self could be a temporary expression of a much larger, universal consciousness that is deeply entangled with the fabric of reality. This shift in perspective challenges traditional views of identity and individuality. The materialist model sees the self as a product of the brain's processes, with consciousness emerging as the sum of neural activity. But if consciousness is quantum, the self might be far more fluid and interconnected. Rather than being a fixed point of awareness, the self could be an expression of a larger, unified field of consciousness that transcends the brain. In this view, consciousness is not an isolated, local phenomenon, but an open system that extends beyond the brain. Our thoughts, memories, and experiences might not be confined to our minds, but could be connected to a deeper quantum field that links us to the entire universe. This interconnectedness raises profound questions. What is the nature of the self? Where does the mind end and where does the universe begin? And if consciousness is truly non-local, does this mean that our individual selves are not separate from the universe, but part of a larger, unified consciousness? A quantum field of consciousness. At the core of the quantum mind hypothesis is the idea that information is not confined to local systems, but is part of a non-local field that transcends the boundaries of the brain and body. If the brain functions as a quantum information processor, then consciousness itself may be part of a larger, universal information system, one that spans the entire universe. In the holographic universe model, for instance, all the information that makes up the universe is thought to be encoded on a two-dimensional surface, and our perception of reality is a projection of that information. If consciousness is tied to the processing of quantum information, then the mind could be entangled with the quantum field that governs the entire universe, allowing us to experience a unified reality in which the self is not separate, but interconnected with all things. The ultimate paradigm shift. The materialist view of consciousness holds that the mind is a local phenomenon generated by the physical processes of the brain. In this view, the brain's neurons form a network that processes sensory information, produces thought, and generates the subjective experience of consciousness. The mind is a product of the brain, and when the brain dies, consciousness ends. The quantum view, on the other hand, suggests that consciousness is non-local, a phenomenon that arises not just from the brain's neural activity, but from the quantum interactions that occur within and beyond it. In this view, consciousness is not confined to the brain, but is connected to the quantum field that spans the universe, linking all minds and all experiences. The self is not a fixed, isolated entity, but part of a larger unified consciousness, deeply entangled with the fabric of reality itself. This shift in perspective would fundamentally change how we think about the mind, the self, and the universe. It would suggest that the mind is not a self-contained unit, but an open system that taps into a deeper, universal field of consciousness. The boundaries between the self and the universe blur, and the idea of death as the end of consciousness might be replaced by the possibility that consciousness is eternal, simply shifting between forms and states, continuing to exist as part of the larger cosmic consciousness. The quantum mind and the infinite universe. As we explore the quantum mind hypothesis, we begin to see the mind not just as a biological system, but as part of a larger, interconnected quantum field. Consciousness, far from being confined to the brain, may be part of a universal consciousness, deeply entangled with the quantum fabric of reality. This perspective challenges the traditional materialist view of the mind and invites us to consider the profound possibility that we are not separate from the universe, but intimately connected to it, part of an infinite, non-local system of consciousness. As we continue to explore the nature of consciousness, it is clear that the quantum view opens up a new paradigm, one where the boundaries between self and universe are not fixed, but are fluid and interconnected. In this view, consciousness is not a local phenomenon, but a universal process reaching across space and time, tapping into the very fabric of reality itself. Consciousness as a field, the brain as a receiver of universal information. What if consciousness is not simply a byproduct of neural activity in the brain, but something more profound, a field that interacts with the quantum world, a universal force that connects everything in the cosmos? Imagine that consciousness is not confined to the brain, but instead exists as an informational field, much like gravity or electromagnetism, permeating the universe and linking all living beings. Could the brain be more than just a biological computer, merely processing information? What if it acts instead as a receiver, a conduit for the flow of universal information, tuning into a vast quantum field that transcends the physical confines of the body. In this section, we will explore this radical idea that consciousness may be a quantum field, a field of information that interacts with the brain and the quantum realm, shaping our thoughts, experiences, and sense of self. This theory challenges the traditional materialist view that consciousness is strictly a product of the biological brain, suggesting instead that the brain might be part of a much larger, interconnected system of information that extends throughout the cosmos. We'll examine the implications of consciousness as a quantum field, akin to gravitational or electromagnetic fields, and consider how this might help explain the profound sense of non-locality, the feeling that we are connected to something greater than ourselves. If consciousness is indeed a field, then perhaps the brain is not an isolated, self-contained entity, but an active part of a vast, universal network of information and awareness. Consciousness as a product of the brain. The classical view of consciousness has long been that it arises exclusively from the activity of the brain. According to this view, the brain processes sensory input through complex neural networks where information is passed between neurons via synapses. These networks of neurons and synaptic connections generate the electrical and chemical signals that form the basis of thoughts, memories, and perceptions. In this model, the brain is a biological computer receiving input, processing it, and producing output in the form of behavior, decisions, and subjective experience. Consciousness is seen as an emergent property of this complex system, resulting from the interactions of neurons and neural circuits. It is confined to the brain and is tightly bound to the biological processes that occur within it. The materialist view suggests that the brain creates the mind, and when the brain ceases to function, so does the mind. However, this classical model faces significant challenges when it comes to explaining the subjective nature of consciousness, the qualia of experience. How do neural processes give rise to the vivid inner world of thought, emotion, and awareness? If consciousness is just an emergent property of the brain, why does it feel so real, so personal, and so connected to the higher universe? This is where the theory of consciousness as a field offers a radically different perspective. Instead of seeing consciousness as something produced inside the brain, we will explore the possibility that it is an external force that the brain taps into, a force that exists across the cosmos, linking all beings and all things. A quantum field of information. What if consciousness is not confined to the brain, but instead operates like a field, similar to the way gravitational and electromagnetic fields permeate space? In this view, consciousness would be a universal field, a non-local phenomenon that exists throughout the universe, influencing everything within it. In quantum mechanics, the universe is understood to be filled with a quantum field, a field that governs the behavior of particles at the smallest scales. This field is responsible for phenomena like superposition, where particles can exist in multiple states at once, and entanglement, where particles can be instantaneously connected regardless of distance. The quantum field is a non-local force, meaning that it is not bound by the traditional constraints of space and time. It transcends the limitations of classical physics and connects everything in the universe in ways that are invisible to our everyday perception. Could consciousness be a similar field, one that exists everywhere and is interconnected with the Arya quantum field? If consciousness is a quantum field, it would imply that it is not limited to the brain, but is instead part of a universal system of information that stretches across space and time. The brain, in this view, would not generate consciousness, but rather tune into it like a radio receiver picking up a signal from the air. This theory suggests that consciousness is an informational field, not something that originates within the brain, but something that the brain receives, processes, and interprets. Just as electromagnetic waves exist independently of the devices that detect them, consciousness might exist as a field that is independent of the brain, with the brain simply acting as a receiver or transducer. The brain as a receiver. Tuning into the quantum field. If consciousness is indeed a quantum field, then the brain might function as a receiver, an organ that tunes into and processes this quantum information. This would mean that the brain does not generate consciousness, but rather receives it from the quantum field, interpreting and expressing it through neural processes. In this view, the electrical activity in the brain could be a manifestation of the interaction between the brain's neural network and the quantum field. The brain's neurons and synapses could act as quantum transducers, translating quantum information into classical information that we experience as thoughts, perceptions, and emotions. The brain would be like a quantum antenna, picking up signals from the quantum field and decoding them into the conscious experience of the mind. This theory would also explain the sense of non-locality that many people experience in altered states of consciousness, such as in meditation or near-death experiences. If consciousness is a non-local field, then our experience of self-awareness might not be confined to the brain, but could extend into the quantum realm, where space and time no longer have the same meaning. In this state, we could experience oneness with the universe, feeling connected to everything and everyone, as though the boundary between self and universe has dissolved. Blurring the boundaries between self and universe. If consciousness operates as a quantum field, the distinction between the self and the universe begins to blur. Instead of being a separate entity, isolated within the confines of the body, the self could be seen as part of a much larger interconnected system of consciousness. The brain, acting as a receiver of universal information, would be one of many points in a vast non-local network of conscious awareness. In this view, consciousness is not something that is produced solely within the brain, but is a fundamental aspect of reality itself, a universal force that transcends the individual. The self, rather than being a self-contained entity, is part of a larger cosmic awareness, interconnected with all other beings and all of existence. This shift in perspective would have profound implications for how we understand identity, consciousness, and reality. If the mind is a quantum field, then individuality might not be as fixed as we once thought. Instead of seeing the mind as a static, isolated entity, we might view it as an open system, constantly interacting with and receiving information from the quantum field that surrounds us. The brain, in this sense, would be an interface through which universal consciousness expresses itself. A fundamental shift. The classical materialist view of consciousness that the brain generates, the mind assumes that consciousness is a localized phenomenon, confined to the body and the brain. It sees the self as a product of neural processes, with little or no connection to the greater universe. The quantum view, however, suggests that consciousness is part of a universal field of information, connected to the quantum fabric of reality. In this view, the brain is not a generator of consciousness, but a receiver, tuning into the quantum field and processing information from it. The self is not an isolated, self-contained entity, but part of a much larger, non-local system that links all minds, all beings, and all things. This shift in perspective opens up new possibilities for understanding the nature of consciousness, the self, and the universe. If consciousness is a quantum field, then perhaps the self is not limited by space and time, but is interconnected with the cosmic consciousness that transcends the boundaries of the brain and body. The non-local nature of consciousness suggests that we are not isolated individuals, but part of a unified whole connected to the universe itself, the quantum mind and the infinite field of consciousness. As we explore the idea of consciousness as a quantum field, we begin to see the mind not just as a biological machine, but as part of a much larger, interconnected system of universal information. The brain, in this view, does not generate consciousness, but receives it, tuning into the quantum fabric of reality and translating universal information into the subjective experience of self-awareness. If consciousness is indeed a field, it would explain the profound sense of non-locality and interconnectedness that many people feel in moments of deep meditation, mystical experience, or profound insight. It suggests that the self is not an isolated entity, but an expression of a larger unified consciousness connected to the quantum field that underpins all of reality. The quantum mind offers a radically new way of understanding consciousness, one that transcends the brain and body and connects us to the infinite, interconnected field of universal awareness. Experiments and evidence. Quantum effects in the brain. Could the brain, that complex biological machine, be more than just our processor of classical information? Could it be that quantum effects are playing a crucial role in how we think, feel, and experience the world? This is the bold question that researchers have been grappling with for decades, and it's one that challenges our most fundamental understanding of consciousness, reality, and the brain itself. In this section, we will explore the experimental evidence and ongoing studies that suggest the possibility of quantum processes occurring within the brain. We will review groundbreaking research into quantum coherence, quantum biology, and the microtubules in neurons which have been proposed as potential sites for quantum computation. Alongside the promising evidence, we'll also examine the skepticism and controversies surrounding these theories, as well as the challenges scientists face in testing quantum effects in such a warm, wet environment as the brain. Finally, we will contrast the uncertainty and skepticism with the compelling evidence that points to quantum processes at play within the brain, shedding light on the ongoing experiments and discoveries that continue to shape our understanding of quantum consciousness. A radical hypothesis. The hypothesis that quantum effects might play a role in brain function has been controversial from the very beginning. The classical view holds that the brain operates like a biological computer, processing information using neural networks in a deterministic, classical fashion. The idea that the brain might be a quantum information processor challenges this view, suggesting that processes like quantum coherence, entanglement, and superposition could be involved in the generation of consciousness. At the heart of this hypothesis is the idea that certain parts of the brain, particularly the microtubules in neurons, could support quantum effects. The Orch-OR theory, proposed by Roger Penrose and Stuart Hameroff, suggests that microtubules, the tube-like structures within neurons, could be sites for quantum computation, where quantum states are orchestrated and reduced, giving rise to conscious experience. The theory implies that quantum coherence in these structures could enable the brain to process information in ways that classical physics cannot explain. But how can quantum effects, which are typically observed in the cold, isolated conditions of laboratory experiments, possibly exist in the warm, wet, and noisy environment of the brain? This is one of the main challenges that quantum brain theories face. Yet some scientists argue that certain biological systems might have evolved to protect and maintain quantum coherence, even in less than ideal environments. The case for quantum coherence in the brain, one of the most compelling areas of research. Supporting the quantum brain hypothesis is the discovery of quantum coherence in biological systems. Quantum coherence refers to the phenomenon where particles or systems remain in a superposition of states and interact in ways that cannot be explained by classical physics. In photosynthesis, for instance, recent studies have shown that certain photosynthetic proteins are capable of maintaining quantum coherence over long distances. This suggests that biological systems might be capable of utilizing quantum effects to enhance their efficiency. Could the brain similarly harness quantum coherence to process information more effectively than classical systems? Studies into Quantum biology have also revealed that other organisms, such as birds, may use quantum effects to navigate. The cryptochrome proteins in birds' eyes are believed to be responsible for the quantum entanglement that helps them sense Earth's magnetic field and navigate long distances during migration. If quantum coherence can occur in living organisms, it raises the possibility that the brain might also be capable of utilizing these same quantum effects. Microtubules and quantum computation in the brain. The idea that quantum effects could be present in the brain often centers around microtubules, which are components of the cytoskeleton inside neurons. Microtubules are responsible for maintaining the structure of the cell and facilitating intracellular transport. But Penrose and Hameroff's Orch-OR theory proposes that these microtubules may also play a role in the quantum processes that give rise to consciousness. Microtubules are composed of tubulin proteins, which could, in theory, support quantum coherence and entanglement. Penrose and Hameroff suggest that these proteins might form quantum states, which could be orchestrated to produce conscious experience. According to their theory, objective reduction, a process where quantum superposition collapses into a single state, could be the key to the experience of consciousness, with microtubules acting as the site of this collapse. While this theory has its critics, it provides a plausible mechanism for how the brain could operate as a quantum processor, capable of accessing a deeper level of information and connecting to the greater quantum field. But what evidence is there to support this theory? Searching for quantum effects in the brain over the years, several experimental studies have attempted to test the hypothesis that quantum effects might be present in the brain. These studies often focus on quantum coherence in biological systems, the role of microtubules in neurons, and whether the brain can maintain quantum states in its warm, wet environment. One of the most important pieces of evidence comes from research into quantum coherence in biological systems, such as the photosynthetic reactions mentioned earlier. In particular, scientists have discovered that certain biological molecules, including those in the eye, plants, and even bacteria, can maintain quantum coherence under relatively warm and wet conditions. This challenges the classical assumption that quantum effects can only occur in low-temperature, isolated environments. In the brain, however, the situation is more complicated. For quantum effects to be maintained, the quantum states would have to be protected from the noise of the surrounding environment. This is why the idea of quantum coherence in microtubules is so controversial. How could such fragile quantum states survive the chaotic environment of the brain with its constant flow of heat, electrical signals, and chemical reactions? Controversies and challenges, the idea of quantum effects in the brain is not without its critics. One of the primary objections is that the brain operates at too high a temperature to support quantum coherence. Quantum states are notoriously fragile, and the warm, wet environment of the brain seems ill-suited for maintaining the delicate balance required for quantum effects. Critics also point out that the brain's neural networks are primarily governed by classical biological processes, and there is no direct evidence that quantum effects are involved in consciousness. The Orch-OR theory and other quantum brain hypotheses remain highly speculative, with many researchers expressing doubts that quantum mechanics could play a significant role in the brain's function. Furthermore, the challenge of testing quantum consciousness is enormous. Quantum effects are notoriously difficult to observe, especially in systems as complex as the brain. The brain's neural networks are so intricate that isolating and studying the potential quantum effects in the microtubules requires an unprecedented level of precision and control, ongoing research and future directions. Despite these challenges, there is ongoing research aimed at testing the quantum brain hypothesis. Scientists are exploring quantum coherence in other biological systems, including the brain. Some studies have focused on the role of microtubules in maintaining quantum states, while others are investigating whether quantum entanglement could be involved in neural communication. Researchers are also exploring the potential of quantum biology to explain aspects of brain function that cannot be accounted for by classical physics. For instance, experiments are underway to test whether entanglement could play a role in the brain's information processing. Additionally, new technologies are being developed to observe quantum effects in biological systems in real time, which could offer critical insights into how quantum processes might be integrated into brain activity. Skepticism versus compelling evidence. The quantum brain theory is certainly not without its skeptics. Many researchers remain unconvinced that quantum effects play a significant role in consciousness, citing the challenges of maintaining coherence in the brain's warm, noisy environment. Yet, the evidence for quantum effects in other biological systems is compelling, and the Orch-OR theory provides an intriguing framework for how quantum coherence might manifest in the brain's microtubules. As new experiments and technologies continue to emerge, the quantum brain hypothesis may find more empirical support. Until then, the debate remains open. Is the brain a purely classical machine, processing information in a deterministic manner, or is it a quantum processor tapping into a deeper layer of reality and connecting with the universal quantum field? The quantum mind and the future of consciousness. The search for quantum effects in the brain is still in its early stages, and many questions remain unanswered. The evidence so far is promising, but the challenges of testing quantum consciousness in such a complex and dynamic system as the brain are immense. Nevertheless, the possibility that the mind operates not only according to classical physics but also quantum processes could open up a new frontier in our understanding of consciousness, reality, and the universe itself. As researchers continue to explore the intersection of quantum mechanics and neuroscience, we may one day find the evidence needed to support the theory of the quantum mind. Until then, the journey into the mysteries of consciousness will continue to challenge our most fundamental assumptions about the nature of reality and the mind. Entangled minds. Could we be psychically connected? What if our minds are not isolated, self-contained entities, but rather part of a vast, interconnected network of consciousness? What if, instead of operating within the strict boundaries of the brain and the body, our thoughts, feelings, and perceptions are linked across space and time through an invisible, non-local connection that binds us all? Could quantum entanglement, the phenomenon where particles become instantaneously connected no matter how far apart they are, be the key to understanding psychic phenomena such as telepathy, remote viewing, and intuition? For centuries, humans have reported strange, seemingly inexplicable experiences, moments of intuitive knowledge, sudden insights, and even the ability to know what someone else is thinking, despite the physical distance between them. These experiences, often labeled as psychic phenomena, have been dismissed by much of mainstream science as mere anomalies or superstition. However, as we delve deeper into the mysteries of quantum mechanics and non-local consciousness, we begin to ask a provocative question. Could entanglement and quantum connections provide a scientific explanation for what we call intuition or telepathy? In this section, we will explore the idea that quantum entanglement could explain some of the mysterious experiences that transcend the limits of classical psychology and neuroscience. We will examine the possibility that consciousness is non-local and entangled, and how this might enable minds to connect in ways that go beyond space and time. We will also contrast the classical psychology view, which sees the mind as a localized, biological system, with the non-local, entangled view of consciousness, which suggests that our minds could be interconnected across vast distances. The mind as an isolated entity. In classical psychology, the mind is viewed as a localized phenomenon, a product of the brain and nervous system. According to this perspective, All thoughts, emotions, and behaviors arise from the neural activity of the brain. Consciousness is a result of the complex interactions between neurons, synapses, and chemicals, and it is entirely bound to the body and the physical processes of the brain. In this view, the mind is an isolated, self-contained system. Psychic phenomena such as telepathy or precognition are seen as anomalies, rare occurrences that cannot be explained by the known laws of physics and biology. From a classical perspective, there is no mechanism for the mind to influence or be influenced by other minds in a non-local way. Our thoughts are our own, and our awareness is limited to our body and brain. This materialist view of the mind works well for explaining much of human behavior and cognition, but it faces significant challenges when it comes to accounting for psychic experiences. How can we explain the feeling of knowing someone is thinking of us, or suddenly having a vivid vision of a distant place or person? How do we account for the strange phenomenon of telepathy, where thoughts seem to be transmitted directly from one mind to another without any physical connection? The quantum view of the mind enter the quantum mind hypothesis, which suggests that consciousness might not be confined to the brain at all, but could instead be part of a non-local system. Quantum mechanics, the science that governs the behavior of particles at the smallest scales, reveals a world that is radically different from our everyday experience. In the quantum realm, particles are not confined to local space, but can exist in superposition multiple states at once and can become entangled, meaning their states are connected instantaneously, no matter how far apart they are. Could these quantum effects be involved in consciousness? Could the mind be part of a larger non-local system of consciousness that is entangled with other minds, allowing for experiences like telepathy, remote viewing, and intuition? If consciousness is a quantum phenomenon, then it might not be confined to the brain but could extend across space-time, connecting us to one another and to the universe in ways that classical psychology cannot explain. A bridge between minds. At the heart of this idea is quantum entanglement, the phenomenon where two or more particles become linked, such that the state of one particle instantaneously affects the state of another, no matter how far apart they are. This non-local connection challenges our classical understanding of space and time, suggesting that information can be transmitted across vast distances without the need for a physical medium. Could entangled particles be a metaphor for entangled minds? If quantum effects can link particles across space and time, might it be possible for minds to become entangled, two sharing information in a way that transcends the limitations of the brain and body? This idea suggests that our minds could be part of a much larger unified consciousness, one that is deeply interconnected with the quantum fabric of reality. Just as quantum particles can influence each other instantaneously, perhaps our thought and feelings can be transmitted to other minds without the need for physical signals. This could explain phenomena like telepathy, where two people seem to share thoughts or experiences without any sensory input, or remote viewing, where someone perceives distant events or places without any apparent means of information transmission. Could quantum mechanics explain psychic phenomena? The idea of entangled minds offers a potential explanation for many of the psychic phenomena that have long eluded scientific understanding. If our minds are entangled, interconnected through a quantum field, then we might experience what we perceive as telepathy or intuition, because our consciousness is linked with the consciousness of others, regardless of distance. For example, when we think of a distant loved one and then receive a call from them, or when we sense someone's emotions without them saying a word, this could be explained by the idea of quantum entanglement. Our minds could be connected in ways that are not confined to space or time, allowing for the direct transmission of information across the quantum field. This idea also extends to the phenomenon of precognition, where people seem to have knowledge of future events before they happen. Could this be a result of the mind's ability to access non-local information that is not bound by the constraints of time but exists in a quantum state of potential? In this view, psychic experiences are not supernatural occurrences, but natural phenomena that arise from the non-local connections between minds facilitated by quantum mechanics. Skepticism and controversy is their proof. While the idea of quantum consciousness offers a fascinating potential explanation for psychic phenomena, it remains highly controversial. Mainstream scientific skepticism is strong, especially when it comes to applying quantum mechanics to human cognition and behavior. Critics argue that the warm, wet environment of the brain is far too chaotic to support quantum coherence, which typically occurs in isolated, low-temperature systems. They also point out that there is no direct evidence linking quantum processes to psychic phenomena. Additionally, psychic phenomena such as telepathy and remote viewing are still seen by many as unproven, with skeptics arguing that these experiences can be explained by psychological mechanisms such as coincidence, perception biases, or even fraud. Controlled experiments in parapsychology have produced mixed results, and there is no consensus within the scientific community regarding the existence of psychic abilities. Testing the quantum mind. Hypothesis. Despite these challenges, research into quantum consciousness is ongoing. Some scientists are exploring the possibility that quantum processes could play a role in the brain's function, particularly in areas like memory, decision-making, and perception. Studies into the role of microtubules in neurons and their potential to support quantum coherence continue to grow. These studies aim to provide a deeper understanding of how the brain could function as a quantum processor, and whether quantum mechanics could indeed explain non-local connections between minds. In addition, parapsychological research continues to test psychic phenomena under controlled conditions. While results remain controversial, some experiments have shown statistically significant results that suggest there might be more to the phenomenon of psychic connection than meets the eye. These studies, while still controversial, offer intriguing possibilities for the role of quantum entanglement in psychic experiences, the entangled mind, and the future of psychic science. The idea that quantum entanglement could explain psychic phenomena such as telepathy, remote viewing, and intuition challenges our current understanding of the mind, consciousness, and reality. While skepticism remains high, the potential for a quantum view of consciousness opens up new avenues for exploring the deeply interconnected nature of existence. Could the mind truly be entangled with other minds, connected across vast distances and through time? Could psychic phenomena be the result of non-local connections facilitated by quantum mechanics? These questions remain open, but as research into quantum consciousness and psychic science continues to evolve, we may one day uncover the true nature of the entangled mind. The cosmic web. Are we entangled with the universe? Imagine a universe where everything, every particle, every atom, every thought is not separate, but interconnected, part of a vast, entangled web that spans space and time. What if the boundaries between self and universe are not as clear-cut as we've been taught? What if the fabric of reality itself is a quantum system where every particle is entangled with every other particle, forming a unified whole that transcends the physical limits of space and time? This idea, once relegated to the realms of philosophy and spirituality, is now beginning to receive attention from quantum physics. The concept of quantum entanglement, where particles are instantaneously connected, no matter how far apart they are, has led some scientists to ask a profound question. Could consciousness itself be part of this universal entanglement, making us not isolated, self-contained minds, but non-local beings deeply connected to the cosmic web of existence? In this section, we will explore the fascinating possibility that consciousness is not confined to the brain, but is instead entangled with the universe. We'll look at both philosophical and spiritual ideas of cosmic interconnectedness and explore whether quantum mechanics could offer a scientific basis for these ancient concepts. Could the brain's quantum entanglement provide a bridge between science and spirituality, revealing a universe that is not just made up of independent, isolated parts, but is instead a unified whole, interconnected at the deepest level? A fragmented universe. For centuries, the dominant view of the universe in Western science has been that it is a collection of separate, independent objects, each governed by the laws of classical physics. In this model, consciousness is seen as an isolated phenomenon generated by the brain and confined to the body. The universe is made up of individual systems, atoms, particles, galaxies that interact according to deterministic physical laws, but they are ultimately separate and distinct from one another. This view, known as materialism, holds that everything can be explained by the interactions of matter and energy, and that consciousness is simply a byproduct of the brain's neural activity. In this framework, the self is seen as a localized entity, bound to the physical world and independent of the greater universe. The mind is separate from the body, and the body is separate from the cosmos. This materialist view has been incredibly successful in explaining much of the physical world. It has led to breakthroughs in medicine, technology, and our understanding of the universe on both the microscopic and macroscopic scales. However, this perspective has significant limitations, particularly when it comes to explaining consciousness. How do the neurons and synapses in the brain give rise to the subjective experience of self-awareness? Why does it feel as though we are more than just biological machines, but rather aware of our existence in a way that goes beyond physical processes? The web of reality quantum physics, with its strange and counterintuitive principles, offers a radically different view of the universe. In the quantum world, particles do not exist as separate, isolated entities. Instead, they exist in a state of superposition where they can be in multiple states at once, and they can become entangled, meaning that their properties are linked, even if they are separated by vast distances. This entanglement means that when one particle is measured or altered, the other particle's state is instantly affected, regardless of the distance between them. This phenomenon of quantum entanglement has led some scientists to propose that the universe itself might be a vast, interconnected quantum system where everything from the smallest particles to the largest galaxies is linked in a web of non-local connections. Rather than being a collection of separate parts, the universe might be a unified whole where every particle, every object, and every mind is part of a greater cosmic fabric that transcends the physical boundaries of space and time. Could this quantum interconnectedness extend to consciousness itself? Could our minds be entangled with the universe, connected to a larger non-local field of awareness that transcends the physical limits of our brains and bodies? A non-local consciousness. If consciousness is a quantum phenomenon, it follows that it might not be confined to the brain, but could be part of the universal quantum field. This idea challenges the classical materialist view that the mind is a localized phenomenon generated by the brain's neural activity. Instead, it suggests that consciousness might be a non-local process, one that extends beyond the brain and is entangled with the quantum fabric of reality. In this view, the brain would not generate consciousness, but would act as a receiver or transducer, picking up and processing information from the universal quantum field. The mind would be an open system, deeply connected to the cosmos, able to access non-local information and experience a sense of interconnectedness with all things. The self, rather than being a separate, isolated entity, would be an expression of this larger universal consciousness, deeply entangled with the world around it. This perspective suggests that individual consciousness is not as fixed and isolated as we typically believe. Instead, it is part of a vast web of interconnected minds, each of which is connected to the larger cosmic consciousness. The separation between self and other, body and mind, and even mind and universe, begins to blur, as we realize that we are all part of a much larger entangled whole. The idea of a unified, interconnected reality is not new. Many philosophical and spiritual traditions have long posited that consciousness is not localized within the body, but is instead part of a greater cosmic consciousness. In Eastern philosophies like Vedanta and Buddhism, the concept of oneness suggests that the individual self is an illusion, and that all things are connected through a single, universal consciousness. In these traditions, the ego is seen as a temporary, illusory construct, and true enlightenment comes from realizing the unity of all things. In Western mysticism, too, the idea of cosmic interconnectedness has been explored. The Hermetic tradition, for example, teaches that as above, so below, meaning that the macrocosm, the universe, and the microcosm, the individual, are reflections of each other, interconnected at the deepest level. In this view, consciousness is not a local, isolated phenomenon, but is part of a greater unified field that transcends the individual self. These ancient ideas of cosmic interconnectedness are strikingly similar to the concepts of quantum entanglement and non-local consciousness in modern physics. Could it be that both spiritual traditions and quantum mechanics are pointing to the same truth, that consciousness is not limited to the brain, but is part of a larger unified reality where everything is connected at the deepest level? The contrast between the materialist view of the brain as an isolated, self-contained entity and the quantum view of the mind as part of a vast, interconnected system of consciousness is profound. In the materialist view, consciousness is a product of the brain's biological processes generated by the interaction of neurons and synapses. The mind is seen as a localized system independent of the universe, and when the brain ceases to function, consciousness ends. In the quantum view, consciousness is not confined to the brain, but is part of a non-local field that connects all things. The brain functions as a receiver, tuning into the universal quantum field and processing the information it receives. In this view, consciousness is a unified, interconnected phenomenon linked to the fabric of reality itself. The mind is not an isolated entity, but part of the larger cosmic web, deeply entangled with the universe. This shift in perspective has profound implications for how we understand consciousness, identity, and reality. If the mind is part of a unified quantum system, then the boundary between self and universe begins to dissolve. The sense of separation we feel between ourselves and the world is an illusion, and the ego, the belief in an isolated, separate self, is merely a temporary construct. Implications for consciousness. If the universe is indeed a vast, interconnected quantum system, then our consciousness is not separate from it, but part of it. Every thought, every feeling, and every experience is linked to the universal field of information that connects all things. In this view, the self is not confined to the body or brain, but is a reflection of the larger cosmic consciousness, entangled with the universe at every level. This perspective offers a scientific framework for understanding the deep sense of interconnectedness that many people experience in moments of spiritual insight, meditation, or profound connection with nature. It suggests that the cosmic web is not just a metaphor, but a real quantum system that binds us all together. We are not isolated individuals, but non-local beings connected to the infinite, universal field of consciousness. The unified consciousness of the universe, as we explore the possibility of quantum consciousness, we begin to see a universe that is far more interconnected and unified than we ever imagined. Consciousness is not an isolated phenomenon confined to the brain or body, but part of a greater, non-local system that connects all things. The mind is not an independent entity, but a reflection of the cosmic consciousness, deeply entangled. with the universe itself. This new understanding of consciousness challenges the classical materialist view, suggesting that we are not separate from the universe, but integral parts of it. We are not isolated minds, but non-local beings, part of a vast, interconnected cosmic web where every thought, every feeling, and every experience is part of the greater, unified consciousness that permeates all of reality. The future of consciousness and the quantum connection. As we stand on the precipice of understanding the nature of consciousness, we find ourselves gazing into an abyss of mystery, wonder, and possibility. For centuries, human beings have asked profound questions. What is consciousness? Where does it come from? What is the nature of the self? We have explored the brain, dissected its neural networks, and sought to understand how the firing of neurons gives rise to thoughts, emotions, and awareness. But as we've journeyed through this exploration, we've uncovered a deeper, more elusive truth, one that challenges our most fundamental assumptions about the mind, the universe, and our place within it. Could it be that consciousness is not just a biological phenomenon? Could it be that the mind is not confined to the brain, but is instead part of a larger, non-local system, a vast quantum field that connects us to everything, everywhere, and every when? Could quantum entanglement in the brain, as we've explored, explain not only how we perceive the world, but also our connection to it, and even to each other? As we reflect on the profound implications of the ideas we've examined, the possibility of the brain as a quantum information processor, the concept of entangled minds, and the idea that consciousness itself is a part of the very fabric of the universe, we find ourselves confronted with a thought-provoking question. If our minds are truly entangled with the cosmos, what could we unlock about the universe and ourselves in the future? Beyond the classical view of consciousness, for centuries, the materialist view of consciousness has dominated scientific thought. According to this perspective, the mind is a byproduct of the brain's neural activity, and consciousness is simply a result of the electrical and chemical signals passing through the brain's complex networks. This classical view treats the mind as a localized phenomenon confined to the brain with little to no connection to the greater universe. Yet the more we delve into the mysteries of quantum mechanics, the more we begin to realize that the universe is not a collection of separate, isolated objects, but a vast, interconnected system. The phenomena of quantum entanglement and non-locality suggest that particles, and perhaps even consciousness itself, are not bound by the limitations of space and time. Could consciousness too be part of this unified quantum system, entangled with the universe at the deepest level? In the quantum view, consciousness is not a self-contained entity, but a non-local phenomenon that exists beyond the confines of the brain. The brain might not generate consciousness, but could instead serve as a receiver, a transducer of quantum information. This perspective challenges the classical model and invites us to rethink our understanding of the mind, the self, and the universe. If consciousness is truly non-local, then the boundaries between self and universe begin to blur. No longer are we isolated beings separated from the world around us by the walls of our bodies and minds. Instead, we are part of a much larger quantum field, a web of interconnected consciousness that spans the cosmos. In this view, the self is not a static, self-contained entity, but an expression of a larger, unified consciousness. Our thoughts, emotions, and perceptions might be part of a universal information system where our individual minds are entangled with one another and with the greater quantum field that governs the universe. The experience of separation, the sense that we are disconnected from the world and from each other, could be an illusion, a byproduct of our limited perception. As we expand our understanding of the mind through the lens of quantum mechanics, we begin to see that the self is not confined to the brain, but is part of the quantum fabric that connects all things. In this context, intuition, telepathy, and other seemingly psychic phenomena may no longer seem so mysterious. Rather than being anomalous or supernatural, they could be natural expressions of a non-local consciousness that transcends the limits of space and time. Unlocking the mysteries of the mind, the idea that the brain might function as a quantum receiver opens up exciting possibilities for the future of consciousness research. If the brain is capable of quantum coherence, the ability to maintain quantum states in the neural networks, then it could potentially access non-local information from the quantum field. This would explain how our minds could be connected to the universe in ways that go beyond what classical science can currently explain. Imagine a future where we can tune into the quantum field with greater precision, much like a radio receiver, tuning into different frequencies. We could learn to enhance our connection to the universal consciousness, tapping into the vast information that lies beyond our individual minds. This would not only transform our understanding of consciousness, but could also revolutionize our approach to healing, intuition, and knowledge. The possibilities for personal and collective growth would be boundless. Quantum consciousness and the unity of all things, as we reflect on these ideas, we are reminded of ancient spiritual traditions that have long spoken of cosmic interconnectedness. The idea that all things are unified through a deeper, universal consciousness. From the mysticism of the East to the philosophy of the West, the concept of a cosmic web of interconnected minds has been a recurring theme throughout human history. In these traditions, the self is seen not as an isolated entity, but as part of a larger universal consciousness that transcends space, time, and physical boundaries. This idea aligns closely with the modern quantum view of consciousness, which suggests that the mind is not confined to the brain, but is part of a greater quantum field, a cosmic web that connects all minds, all matter, and all energy. As we continue to explore the nature of consciousness through the lens of quantum mechanics, we begin to see that the scientific and spiritual perspectives are not in conflict, but are, in fact, converging. The idea that consciousness is a non-local quantum phenomenon opens up new avenues for understanding the unity of all things. Rather than being separate and isolated, we are part of a much larger, interconnected whole, a universe that is deeply entangled and unified at the quantum level. What lies ahead? As we look toward the future, the implications of quantum consciousness are profound. What could we unlock about the universe and about ourselves if we continue to explore the connection between the quantum field and the mind? What if the greatest mysteries of the cosmos, the nature of space, time, and consciousness are not as separate as we once thought, but are part of a larger, unified field that we are just beginning to understand? In the future, we may discover that the mind is not confined to the brain, but is part of a greater cosmic intelligence, a field of information that permeates the universe. As we unlock the secrets of this field, we could begin to harness new abilities, from telepathy to remote viewing, from healing to interdimensional communication. The potential for personal and collective growth is limitless as we tap into the deep interconnectedness of all things. But as we continue this journey, we are left with more questions than answers. If our minds are truly entangled with the cosmos, what else might we discover? Could we unlock the secrets of time travel, interdimensional experiences, or even immortality? What if the universe itself is a reflection of our consciousness, a vast, interconnected web that mirrors the unity of all minds? Toward a new understanding of reality, as we conclude this exploration of the quantum mind and its connection to the universe, we are reminded that our understanding of consciousness is still in its infancy. The quantum revolution has only just begun, and the true nature of the mind, the universe, and our place within it remains one of the greatest mysteries of existence. What we do know is this: the boundaries between self and universe are not as fixed as we once believed. The mind, far from being a biological machine, may be part of a vast, interconnected quantum system linked to the very fabric of reality. As we continue to explore the nature of consciousness, we may one day unlock the deepest secrets of the cosmos, not just through the mind, but as part of the mind of the universe itself. And so we are left with an open-ended thought. If our minds are truly entangled with the cosmos, what could we unlock about the universe and ourselves in the future? The journey has just begun.